Bismillahirrahmanirrahim. Welcome to the second part of the trigonometric function of any angle. This is the second part. In the first part, we spoke about how to find the sixth trigonometric function for any angle. It is not needed to be acute angle. It can be more than 90 degrees. And we spoke about the quadrantal angles, which are the 0, 90, 180, and 270. In this part, we are going to speak about the signs of the trigonometric functions. As we know, in the xy plane, there are 4 quadrants. Number 1, they are numbered counterclockwise. Number 2, number 3, and number 4. In the first quadrant, I know that x is greater than 0 and y greater than 0. So all the trigonometric functions in the first quadrant are positive. In the second quadrant, x is negative and y is positive. From the coordinate from the second coordinate, which is y, I have sine and cosecant are positive. Only sine and cosecant are positive in the second quadrant. In the third quadrant, x is negative and y is negative. So it means that only the tangent and cotangent are positive in the third quadrant. In the fourth quadrant, x is positive and y is negative. So this will give me cosine and secant are positive in the fourth quadrant. And this is given in this table now. Sine, if we are in the positive quadrant, sine and cosecant are positive. In the first quadrant, secant are positive. And the third and fourth are negative, sine and cosecant. Cosine and cosecant, they are positive in the first quadrant and fourth quadrant, but they are negative in the second and the third. Tangent, they are positive in the first quadrant and third quadrant, but they are negative in the second and the fourth quadrant. Why do we need this? We need this sometimes to find the exact value for the trigonometric function. But before doing that, let's try to solve these exercises. Exercises 21 to 26, let theta be an angle in the standard position. State the quadrant in which the terminal side of theta lies. Question number 21. We have sine theta is positive and cosine theta is positive. Now sine theta is positive and cosine positive only in one quadrant. See, sine, we can think about it as in this way. First one, sine is positive in the first and the second. This is sine. Theta is positive in the first and the second. And the cosine is positive in the first and fourth. So the common quadrant is the first one. So question number 21, it is the first quadrant, sine and cosine positive in the first quadrant. So call it Q1, mean first quadrant. 22, tangent is negative and sine is negative. You see this one? Tangent is negative in the second and fourth. You can see this is a tangent. It is negative in the second and fourth. And sine theta is negative in the third and fourth. So the common is the fourth. So the answer for 22 is the fourth quadrant. It is the fourth quadrant. Number 23. See that cosine is positive. See the cosine is positive in the first quadrant and fourth quadrant. Tangent is negative. Tangent negative in the second quadrant and fourth quadrant. So the common is fourth. So the answer for 23 is the fourth quadrant. Now 24. We have sine is negative. Sine is negative in the third and the fourth. This is sine is negative. Cosine is positive. Cosine is positive in the first and fourth. So the common one is the fourth quadrant. Number 25. Take this out. For 25, this is for 25. We are given sine is negative and cosine is negative. Now sine is negative in the third and fourth. Cosine is negative in the second and third. So we can see the common one is the third one. So 25 will give me the third quadrant. Number 26. Tan is negative. Tan negative in the second quadrant and the fourth quadrant. Cosine is negative in the second and third. So the answer for this one is the second quadrant. So the terminal side will be in the second quadrant. Now let's find some exact value for some trigonometric function if we are given only one trigonometric function and also the quadrant in which the terminal side is given. For example, let's find the exact solution. Let's find tangent theta and let's say cosine theta. And you are given sine theta equal to 1/2 and theta is between 90 and 180. Given sine theta equal to 1/2 and theta is between 90 and 180. Now theta between 190 and 80, it means we are in the second quadrant. Theta will be in this quadrant. It is in the second quadrant. And in the second quadrant, we know that y is positive. So second quadrant, we know that x is negative and y is positive. Now sine theta equal to 1/2. And we know sine is y over r. So if we are in the second quadrant, so this is theta, so we can graph triangle there. Okay, this is theta, but I can use this triangle. This is y, this is x, and this is r. Now from the sine theta, which is equal to y over r, we know that y will be 1 and r equal to 2. So I can write this there. Y is equal to, this is 1 and r equal to 2. What's missing is x, so we need to find x. To find x, using the Pythagorean theorem, it is square root of r square minus y square, because this is the right triangle. This will give me square root of 4 minus 1, which is equal to square root of 3. Now I have x, but we have to be careful. We said that x is negative. So it means x must be minus square root. So it is minus square root of 3. We have to be careful about this sign. It is negative because we are in the second quadrant. X is negative. Now I have x. I can find the tangent and cosine theta. Now cosine theta, which is equal to x over r, this is equal, x is minus square root of 3 divided by r, which is 2. So it is minus square root of 3 divided by 2. Tangent theta is equal to y over x. Y is equal to 1. X is minus square root of 3. So we can write it as minus square root of 3 divided by 3. Because we need to rationalize and we shouldn't keep any radical in the numerator. I'm sorry, in the denominator. So it will be minus 1 over square root of 3 or equal to minus square root of 3 divided by 3. And you can see, since you asked me about the second quadrant, we know that cosine is negative and tangent is negative, and that's what we got. Cosine is negative and tangent is negative because they are in the second quadrant. So we have to be careful about the sine of x and y if we know the quadrant. Because this is not acute angle anymore. We are not in the first quadrant. It might be in the second or the third or the fourth quadrant. So this is how to find values for trigonometric function if we know one of the trigonometric function and the quadrant in which the terminal side is given.